Today on Capechi's Corner, we're going to look at complex numbers. Now, when you were in Algebra 1, you use phrases such as all real numbers or no real solution, something like that, when you're finding domain and range and other things. So this is where we're going to talk about imaginary numbers. An imaginary number is a number when squared has a negative result, which again is very different from what you've done in Algebra 1. The letter I, which stands for imaginary number, was invented because people wanted to be able to take a square root of a negative number. And you can't do this if you limit yourself just to real numbers. So an imaginary number is a real number multiplied by I. So I could have 5i, I could have 3i. They're all imaginary numbers. Now, there's two things you need to know about the imaginary unit. The first of all, I squared is equal to -1, and I is equal to the square root of -1. Now, one thing, we're going to talk about complex numbers today, and we're going to get to this a little bit later in the lesson. I'll come back up. But a complex number is a real number plus or minus an imaginary number. So in this example, here's my real number, and there's my imaginary number. Now, in going back, we have a little table here. And going back to what we're given here, you can find imaginary numbers raised to any power. You can come up with a value. So this first column is really the important one. I to the 0 power is 1. Remember, anything raised to the 0 power is 1. I to the first power is I, right? Makes sense. Like 6 to the first power would be 6. Now here it comes back to our rules, right? We have this right here. I squared is equal to -1. And then what happens is I to the third is equal to -I. So think about this. I to the third is equal to I squared times I to the first. So I squared we know is -1. I to the first is I, so that would equal to -I. So if you break it down that way, that might help you so you don't have to memorize everything. I to the fourth is 1. Again, same idea. I squared times I squared is equal to I to the fourth, and I squared is -1 times -1 would give us 1. Now the pattern will continue. So I to the fifth is I. It'll kind of keep going from there. I to the sixth is -1. I to the seventh is -I to the eighth is equal to 1. So you can kind of use that table in finding things such as I to the 27th or I to the 30th. You can use that. All right, so now we're going to perform some operations, and we're going to simplify. We're going to just do a variety of different types of problems and simplifications here. So I have the square root of -100. Well, I'm going to split that up. So in previous problems in Algebra 1, we would be like not possible, no real solution. But now that we know imaginary numbers, we can simplify this. So I can say that is equal to the square root of 100 times the square root of -1. Square root of 100 is 10. Square root of -1 is I. So there's my final answer right there, 10i. Okay, same thing if I'm looking at the square root of -18. Now, 18 isn't a perfect square like the previous problem was. So we're going to simplify that. Highest perfect square is 9. 9 times 2 gives us 18. And then I need to take care of that -1. So this is 3 times the square root of 2 times the square root of I. So what happens is we put that I up in front. So it's 3i times the square root of 2. That radical is always listed last. All right, number 3. I have -5 times 3 gives me -15. I times I gives me I squared. Now remember, I squared is equal to -1. So this gives me -15 times -1 gives me +15. Now, number 4, we're going to break this down. So we know the square root of -9, that's going to give me 3i. Now that we've done a couple, you kind of know how this is going to work out. 3i. And then I have times the negative the square root of -16 gives me 4i. So it gives me 12 times I squared. So it gives me -12. Now, one thing we're not going to do on these, this is a no. We're not going to multiply them together and underneath go -9 times the -16, which gives me the positive square root of 144, which is 12. That's not the answer. It's -12. So you're going to have to simplify that separately. Don't combine those underneath the radical sign. Now I'm looking at number 5. That's not factorable, right? It's x squared plus 81 It's not a perfect square minus a perfect square. It's perfect square plus a perfect square. So we're going to bring that 81 to the other side. X squared is equal to negative 81. Take the square root of both sides. Now remember, if I take the square root of both sides, I have plus or minus. The square root of negative 81 is 9i. So that's going to be our answer there. X is equal to plus or minus 9i. All right, so now we're going to add. Here comes our complex numbers, right? I have a real number, an imaginary number, real number, an imaginary number. So I'm going to combine my real numbers first. So negative 2 and 1 gives me negative 1. 5i and negative 7i gives me negative 2i. And again, we like to list our real numbers first. Now, looking at our next type of problem, I find the values of x and y that makes that statement true. So if you look, I have right before the I have y minus 3. So it's going to be equal to 6. This other part here, this 3x plus 5 is going to equal to 7. 3x minus 5 is equal to 7. Then I just solve. So I have 3x is equal to 12. So x is equal to 4. And then I have y is equal to 9. Now, as always in math, you can substitute that back in and see if you get the right answer. So we can do that. I have 3 times 4 minus 5 plus, and that gives us 9 minus 3i. Simplify that. That's 12 minus 5, which gives us 7. Plus 9 minus 3 is 6. So I have 6i. 7 plus 6i, which is what I started with. So I know that my values for x and y are correct. All right, we did some addition. Now we're going to do some multiplication. Now we're multiplying up two binomials. We like to use FOIL, right? That's the easiest way. That's the way we've been doing in class. So negative 2 times 1 gives me negative 2. Here's my outside. Negative 2 times negative 7i gives me positive 14i. And then my inside gives me 5i times 1, which is 5i. And then my last one, I have 5i times negative 7i, which gives me negative 12i squared. All right, so now we're going to have to simplify that, make sure that we're okay. So what we need to do, so my negative 2 out front, nothing I can do with that. I can combine this, and I have, that gives me plus 19i. Now remember, this I squared is equal to negative 1. So that's actually plus 12. I like to write my real number first. So I have negative 2 plus 12 gives me 10 plus 19i. So that's my complex number simplified. Okay, so now we're going to move on. Again, just we're going to review a little bit just to make sure we're okay before we go forward. Now, if you remember, if I have 6 over the square root of 2, I cannot have a radical on the bottom of my fraction, right, as a denominator. So I'm going to multiply top and bottom. I'm rationalizing the denominator. Top and bottom square root of 2. This gives me 6 root 2 over 2. I simplify when I can. So 6 and 2 on the outside. So my final answer is 3 root 2. Now that's important, just kind of that procedure and going forward. So now we're going to do something similar. I can't have an imaginary number on the bottom. Like I can't have a radical on the bottom. So I'm going to simplify that. Now, to get rid of this, similar to the fraction we did above, I need to multiply by the I, like we multiply both sides by the radical. So I'm going to multiply top and bottom by I. So this is going to give me, I'm going to put this I up front, 6 minus I. And on the bottom, I get 2 times I squared. All right, when I simplify through there, I get 6i minus I squared all over 2I squared. Now again, remember I squared is equal to negative 1. So that gives me 6i on the top plus 1. And on the bottom, I have 2 times negative 1. All right, so to simplify a little bit, again, I like my real number first. So 6 plus 6 to 1 plus 6i. On the bottom, 2 times negative 1 gives me negative 2. So I've seen it this way as an answer, or sometimes you can see they like to split it up sometimes, like on standardized tests. So it's going to be 1 over negative 2 plus 6i over negative 2. We can simplify this. This gives me negative 1/2 minus 3i. So either one, or, you could see from here and there. All right, moving on. Again, going back to our Algebra 1 topics. If I have a binomial on the bottom with a radical, I have to multiply by the conjugate. So what the conjugate is, it's the same binomial, just a different sign. So that gives me 3 minus the square root of 2, 3 minus the square root of 2. So again, I have 6 times the quantity of 3 minus the square root of 2. Now I'm going to use FOIL. 3 times 3 gives me 9. Outside gives me minus 3 root 2. Inside gives me plus 3 root 2. And then last gives me root 2 times root 2 with a negative in front. So it's minus 2. So when I simplify that, I have 6 times the quantity of 3 minus root 2. Now this negative 3 root 2 plus 3 root 2, that's going to simplify. So I have that's all over 7. Now again, sometimes you see it multiplied through. So this gives me 18 minus 6 root 2 all over 7. Either one's okay. Okay, you have a binomial with a radical, you multiply by the conjugate. We're going to do the same sort of thing in the next problem. Okay, so again, I can't have a radical in the bottom. I can't. All right, moving on to the next one. Now, in our denominator, again, we can't have an imaginary number. So like we did in the previous problem, I'm going to multiply by the conjugate. So it's going to be 3 minus 6i. Whatever I do at the bottom, I do to the top. So that's going to give me 2i times 3 minus 6i all over. Now again, we'll set this up and we'll use FOIL. 3 times 3 gives me 9. My outside is negative 18i. My inside is positive 18i. And then I have 6i times 6i. So there's a negative there. 6 times 6 gives me 36. And then I have I squared. Right now, I need to clean it up a little bit. So then it gives me 6i minus 12i squared all over. Now this negative 18i and positive 18i, that's going to zero out. Remember, I squared right here is equal to negative 1. That's going to give me plus 36. So 9 plus 36 gives me 45. Okay. Now, the same thing here. I have 12i squared. That's the same thing as a negative 1, right? I squared. So that also gives me 6i. That gives me plus 12 all over 45. Now, we like to write our real number first. So it's 6 plus 12 plus 6i all over 45. Now, we could also simplify that, right? Everything is divisible by 3. So that gives me 4 plus 2i all over 45 divided by 3 gives me 15. So I've seen, sometimes you see that as an answer. You can also see it broken up more as 4 over 15 plus 2i over 15. Sometimes you see it written like that. All right, let's do another one, multiplying by the conjugate. Again, this is going to be 1 plus I over 1 plus I. This time I have another binomial on the top, so I'm going to use FOIL. So it gives me 2. My outside is 2i. My inside is I. And my last is I squared. All over 1 times 1 is 1. My outside is I. My inside is minus I. And my last is minus I squared. So now I need to just clean it all up. So remember, I squared is equal to negative 1. So I have 2 minus 1 gives me 1 plus 3i on the top. All over. I minus I is going to zero out. This is going to give me minus I squared is plus 1. So 1 plus 1 gives me 2. So again, you could see it written like that, or 1/2 plus 3i over 2. Either way. All right, for the last problem today, let's take a look at a real world example. So in an AC circuit, the voltage, which is V, current, which is C, and impedance, which is I, are related in the formula. V is equal to C times I. So find the voltage. So we're solving for V. When we have the current is C plus 4J, and then we have 9 minus 3J ohms. Okay, so let's see what we have. So I have V is equal to C is 2 plus 4J times I stands for 9 minus 3J. And now we're going to use FOIL. 2 times 9 gives me 18. Outside is minus 6j. Inside is 36j. And the last is negative 12j squared. All right, combine my like terms. I have 18 plus 30j. Now again, negative 12j squared. We're using j instead of an I as the part of the formula. That's still an imaginary number in this particular problem. So that gives me plus 12. So my final answer is 30 plus 30j, and our volts is gonna be our unit for the final answer. 30 plus 30j volts. Okay, great job today with complex numbers. Have a good one.